Hey guys, what's going on? Mr. Simonini here. I hope that you're having a good day so far. This video is all about finding the vertex in vertex form. Tomorrow's video will be about standard form, and the next video after that will be about factored form. Just remember, our goal this week is to find the vertex in all three forms. Remember, if you need to pause this video whenever if you need me to slow down, you can pause it and then rewind it, whatever you do. Just reminding you about that as well. But anyways, the goal this week is to find the vertex in all three, I should say three forms. Let's see if I can squeeze an S. There you go. In all three forms. Reminder, what is a vertex? Remember, the vertex is when you look at a parabola, which looks like a U. The vertex is the minimum point, or what we call, the bottom of the hill. And the vertex is always going to have, it's going to be an ordered pair. So there's an X value and there's a Y value. Or if it's opening down, it would be the highest point, or the maximum, we say. But that will be the vertex there. Again, there's an X and there's a Y. So this is a reminder, what is a vertex? A vertex is the very bottom of the hill or very top of the hill. Or when you look at the parabola, it's where the U starts turning. And it's the most important point that you have to be able to find when you're graphing. Remember, there's three forms. Today, again, this video is all about being able to find the vertex in vertex form. And tomorrow and the other day will be the other forms, but we're just focusing on this today. So how do you find the vertex in vertex form? And it's pretty straightforward. That's why it's called vertex form. So let's look at this example. So remember when we did transformations back in the day, whenever we looked inside, remember inside was your left and right movement. So what was inside of your parentheses, and whatever was outside was your up and down movement. Now remember us talking about this. If you want to write this down, you can. Remember, if it's positive inside, so if you're adding inside, that's going to make it move left. If it's subtraction inside of the parenthesis, then you move right. If it's addition outside of the parenthesis, it would be up. And then if it's subtraction outside of the parenthesis, it was moving down. So again, these are your transformations. So if you look here, we're subtracting inside, which is going to make it move right. So this would be, I guess I'll just keep it green. This would be right 1 because of the -1. You do the opposite of what you think inside. So you think subtraction, oh, that's left. No, it's opposite. So it'd be right 1. And then you also do whatever is outside. In this case is -4. So this would be down 4. So my transformation here is right 1, down 4. So if you look here, the bottom of my hill, in this case, is going to go to right 1, and I want right 1, down 4. And then we know a rough, this is an eyeball sketch, rough sketch of what the quadratic will look like. But if we had to graph it, that's basically what it will look like. Now my vertex here my transformation helps me find it. Or in other words, you can just look at the equation. Whatever is opposite of what's inside, which in this case is -1, is opposite of -1, which is going to be +1. I'm going to put this in a different color. So this would be +1. And then my down 4, whatever number that is, that's going to be my y. So in this case, it'd be -4. You do not take the opposite of that. You take the opposite of what's inside, and you take whatever number is outside after the parenthesis. Axis of symmetry, just remember, technically this is the vertical line that cuts the parabola or cuts the U in half. So just to be clear, the axis of symmetry is a vertical line. So a vertical line that cuts the parabola in half. That is what the axis of symmetry is. So the axis of symmetry is always, always, always going to be a vertical line. Since it's a vertical line, it's always going to be x equals a number. Because we talked about lines on first semester, and remember when it was like x equals 3, it was a vertical line that went through 3 for x. So the axis of symmetry is always going to be vertical and also is always going to go through the vertex. So since it's vertical and always going through the vertex and is always x equals a number, your axis of symmetry, simply put, is always, you guys love the word always, it's always the x of your vertex. So if you want to write that down or remind yourself, whenever your axis of symmetry, it's the x of your vertex. If you look here, what's the x of our vertex? Well, it's 1. So my axis of symmetry is x equals 1. So if you look here, you don't need to graph this ever really, but if I had to graph the axis of symmetry, the axis of symmetry is this vertical line that's going through 1 that cuts the parabola in half. It makes it symmetric, what we say. So that is the axis of symmetry right there. But anyways, what you need to know is always the x of your vertex. All right, I'm going to do some these examples pretty quick now. Kind of dove deep into that one. So if you look at number 2, this negative that's in front of the parentheses, you can somewhat ignore it for now, but next week is going to be really important. The negative makes the parabola go down. It makes it go like that. So whenever it's negative in front, it makes it open down. But it does not change their transformation. So again, plus 5, again, is opposite of what you think. So plus 5 will be, make sure I was right up there. Okay, it would be left 5 and then up 4. My vertex here will be opposite of 5, which would be negative 5, comma 4. My axis of symmetry is the x of the vertex, which is negative 5. So that's number 2. Again, pause it if you need to. Number 3, in this case, there's no parentheses. This is technically can be argued for standard form, but we can actually do transformations here. So there's no parentheses here, so my only transformation is up 7. My vertex here, again, I'm not moving left or right, so this would be 0, 7. And then my axis of symmetry is the x of the vertex. So again, in that case, I'm moving up 7. There's no left or right movement. There's no parentheses. So since there's no parentheses, to take the opposite number of, we say 0, and then the axis of symmetry is x equals 0. This one, again, there's parentheses. If you want to think about this one as like plus 0 outside, you can. The transformation here will be, again, opposite of what you think. So this would be right 7. My vertex here will be, so I'm moving right 7, be 7, opposite of negative 7, 7, and then I have 0 outside. So my axis of symmetry, x equals 7. All right, so please pay attention to the message I sent you of what problems you need to do in the homework. Make sure you do your homework. And again, if you have any questions, then please let me know at d211.org. All right, I hope your day goes okay. And again, let me know if you need anything. Thanks. And here's my email.